Okay, now we're going to do a slightly more complicated balancing equation problem. We'll take a look at this combustion reaction right here. So first thing, again, I want to do is make a list of my reactants, of how many atoms of each type are in my reactants and in my product. So my reactants are the things that are going into the reaction. On the left side of the arrow, my products are the things that are being produced in the reaction on the right side of the arrow. And I'll just go ahead and make a list. So there is carbon, hydrogen, and oxygen in the reactants. And of course, there's going to be the same thing in the products. These are the products. And even though this is just a helpful hint, carbon appears and then oxygen appears second, I personally like to put my list in the same order that I put it in for my reactants. And that way, it's just easier to compare lists and make sure that they are the same. All right, so I'll now start making my count. So in the reactants, there is one carbon atom. There are 3 carbon atoms here and hydrogen atoms. There's 3 hydrogen atoms here and 1 hydrogen atom here. So there are 4 hydrogen atoms. And oxygen appears in 2 places as well. So there are 2 oxygen atoms here and 1 oxygen atom here. So there are 3 oxygen atoms. Now I'll do the same thing for the products. 1 carbon atom, 2 hydrogen atoms in water, and then again, oxygen is in 2 different places, so 2 here and 1 here. And that does complicate things a little bit because you have to be very careful when counting your atoms. Since they're in 2 different places, the coefficient that you add is only going to affect the compound that it is in front of. So you have to be very careful when counting it. In this particular problem, or more complex problems like this, that can become an issue if you're not taking your time and being careful. Okay, so first thing I'm going to do is pick an element and balance it. And at this point in time, the only element that needs to be balanced is hydrogen. So I have 4 in the reactants, 2 in the products. So I want to get this up to 4. Hydrogen only appears in one place, so I'm going to put a coefficient of 2 in front of water, cross the hydrogen out count and the oxygen count out because this coefficient affects those 2 elements. And I'll recount. So now hydrogen has 2 times 2, which is 4. And a lot of times what we want to do is, since I've put a 2 in front of this, just like 2 times this 2 is 4, we want to take this 2 and multiply it by this and say we've got 6. Be very careful not to do that. You have to recount just like you did at the beginning. Oxygen in 2 places, so I have 2 oxygen here. 2 times 1 is 2 oxygens here. So 2 plus 2 gives me 4 oxygens. So again, you have to be really careful to avoid that. So now I have 4 oxygens here and 3 oxygens in the reactant. So I have to balance that out. I cannot add anything to this at this point in time, since this is an even number and I have this 1 over here. This will always be odd. So I can't add anything here to make this a 4. So what I want to do now is just go ahead and add a coefficient of 2 in front of this compound. And now I'm going to cross out all of those since carbon, hydrogen, and oxygen is in this compound. So now I have 2 carbon atoms. I have hydrogen is kind of split. This is a different way of writing this formula. So I have 4 hydrogens times 2, which is 8. And then my oxygen, now I have 2 times 1 plus 2 over here. So now my oxygens are balanced. But in the process, I unbalance my carbon and my hydrogen. So I'm just going to pick one of those and balance that. So I'll start with the carbon. I have 2 carbons in the reactants, 1 in the products. So I want to put a 2 in front of the CO2 in the product. Now again, I will cross out the carbon and I will cross out the oxygen. So now there are 2 carbon atoms. And again, I really have to be careful when calculating this. 2 times 2 is 4. So I have 4 oxygens in carbon dioxide. 2 times 1 is 2. So I have 2 oxygen atoms in water. So 2 plus 4 gives me 6 oxygen atoms. All right, so I've balanced my carbon. Everything else has become unbalanced again, so I'm just going to keep working one element at a time. So at this point, I'll just say I'll pick hydrogen. I have 8 hydrogen atoms over here, 4 hydrogen atoms over here. So what I want to do is delete this or erase this, get rid of that, and I want 8 hydrogen, so I'm going to put a 4 right here, cross out my hydrogen, cross out my oxygen. All right, so now I've got 4 times 2, which is 8. Hydrogen only one place, so that's good. And again, I want to recount my oxygen. So I have 4 times 1, which is 4. 2 times 2, which is 4. So I have 4 plus 4. So that is 8 oxygen. So now my carbon is balanced. My hydrogen is balanced. The only thing left to balance is my oxygen. And since this is a 2, and this is an even number, I can easily add a coefficient here. But I have to think about what that's going to be. I have 2 oxygen atoms over here. I want to get 8, so I need to have 6 oxygen atoms over here because 6 plus 2 is 8, and 8 is what I want. So I have to add a coefficient of 3 in front of this. Cross that out. So 3 times 2 is 6, plus 2 times 1 gives me 8. And now that more complicated problem has been balanced.